Good morning, students. Am I audible? Am I audible? Can everyone hear me? Any one of you unmute yourself and tell me. Harshita, Okay. Good morning, students. Am I audible? Am I audible?
Yes, sir.
Yes, sir.
Fine. So, in my last class, I think we had discussed on the topic of the folds, faults, joints, and unconformities. So, in this class, we shall start our discussion on the site selection. Site selection is very important aspect. As you are a practical civil engineer, once tomorrow you start practicing the civil engineering practically, then site selection for dams, reservoirs, tunnels, bridges, and highways becomes a very important aspect. Okay, so we are in the third module. Okay, so then that is the foundation treatment, geological site characterization, that is dam foundations and rock foundation treatment for dams, reservoirs, heavy structures by grouting, rock reinforcement, tunnels, site investigations, coastlines, and their engineering considerations. After which I'm going to discuss on the ground improvement techniques. Okay, and also the rock quality determination and rock structure rating, with which we will be completing the third module. So coastlines and the engineering considerations have already been discussed in the landforms itself. Okay. So now, tomorrow, if you become a practical practicing civil engineer, then this site selection for dams, reservoirs, tunnels, bridges, and highways becomes a very important aspect. Without having a practical knowledge of all these things, it becomes highly impossible for you to determine the land that is suitable place that is required for building a dam, okay, or even a reservoir, or even a tunnel, or even a bridge, or even a highway. Okay, so dams cannot be built everywhere and anywhere. Okay, it has to be done on between a two valleys itself, adjacent to two valleys itself. Dams has to be constructed, and also the reservoirs also. Tunnels cannot be made everywhere. It should be done in a mountain passes itself. Bridges cannot be done everywhere, but it should be done on a across a river or across a lake or anything like that. Highways, as you know, there are a lot of constraints in the laying of the highways also. So the site selection for all these things plays a very important role, because the places that you choose for construction of dams, either dams or it may be reservoir or even a tunnel or a bridge or a highway, always has got a unique role in civil engineering. Not everywhere you can build a dam, not everywhere you can construct a reservoir, not everywhere you can construct a tunnel or something like that. So therefore, this is very important aspect, and also bear in your mind that this question will always arise in your examinations, irrespective of the marks. It may come for 5 marks, 10 marks, or even the 15 marks. So pay very kind attention. Okay. So to study the physiographic features of the area, that is the shape, the size of the river valley and its stages of development, and also the stability, it is very important, because the shape of the area, as we have already studied in the drainage patterns, the different patterns have got contributions for different types of the rivers. Okay, it has also got controls on the size of the river valleys, and also the stages of its development also, and also finally the stability. All these things are very important on the physiography. This is directly dependent on the physiography of the area. Okay, so you have to understand a very good comprehensive knowledge on the physiography of the area, that is the shape of the area, the size of the area, what amount of river valley it is present, what is its stage of development, either it is present in the youth stage or mature stage or even a old stage, and also what is the stability of the slope if it is being present, if at all slope is being present, what is its stability. All these things plays a very important role. Okay, and also you have to determine the nature and depth of the filling in river channel and dam sites. So cutting and filling are the two aspects which will always be done in canals. Okay, cutting means the cutting of the rocks, and also filling means where the excessive valleys are being present to bring to a flat surface. Okay, cutting and filling is usually done on a river channels at a dam sites. And also you have to delineate the areas which are favorable for location of spillway, that is the discharge of the surface water from the storage reservoir. Once the water is being left out, the seepage water that is being present should also be let out. Okay, you cannot hold them into the in the reservoir itself. Okay, the seepage water should also be discharged. You have to recognize suitable areas which are favorable for the locations. Okay, and also diversion channels, have to have the powerhouses, etc. For all these things, you have to have a very good understanding of the geology of the area. Okay, so coming to the important ones are the lithology of the area, that is whether the lithology that is present in that area is comprising of the pervious rocks or the impervious rock beds. Pervious rock beds means the rocks which are capable of permeability, that is the water can flow through the layers of the area. Okay, impervious rock beds means if the rock strata is impermeable. Impervious means if the rock strata is impermeable, that is no amount of water can be going through the area, it cannot be infiltrated into the layers of the earth. Okay, so that is all dependent on the lithology, that is the rock type that is present in the area. If you go towards Chitradurga and Hosdurga, the groundwater potentiality is very low because the infiltration of the water is very low, because granites usually don't have the capacity to infiltrate through the layers of the area. Okay, groundwater, that is in parts of Chitradurga, Hosdurga and all the places, the groundwater is not usually seen at very low levels, it goes beyond 1000 to 1200 feet. Why? Because the lithology is in such a way that the water cannot penetrate through the layers of the earth. Okay, the rock beds is impermeable. Okay, it is impermeable in nature. So you have to understand the lithology, what is the rock type that is present in that area. And also you have to understand, you have to study the leakage zones, the potential leakage zones through which the water can be infiltrated through the layers, as well as it can be enriched within the groundwater also. Okay, the groundwater also should be enriched, the groundwater also should be enriched by those methods. Okay, so those also plays a very important role. Without the enrichment of the groundwater, you cannot determine the potential leakage zones. Leakage zones are very important in nowadays because the groundwater depletion is very much today, the groundwater exploitation is very excessive. At one point of time, in parts of Malnad and Chikmagaluru, you could expected the groundwater at 300 to 400 feet. But now, in parts of Chikmagaluru and this Shimaga itself, the groundwater has gone more than 800 feet. Okay, this shows the rate of the excessive usage of the groundwater, that is over exploitation of groundwater, and also the over excessive use of the groundwater, also the inefficient method of recharging the groundwater. So groundwater is not being recharged, but the exploitation is being on a very huge scale. So that's why there is a deficit in the recharge systems of the groundwater. So that's why you can see the level of the river has also decreased. Okay, level of the river has also been decreased. That's why the floods and other things are a usual part. Floods and other things are a very common aspect nowadays, because once the groundwater is enriched with the water systems, if the water table in the groundwater is being effluent, then the flooding can be controlled. But when groundwater is not being recharged very properly, then all these things will be possible, like flooding and other things. Okay, so that will be discussed in the next unit, that is next module. So and also you have to understand the structural defects like the joints, faults, folds, bedding planes, the solution channels, all these things. Okay, you have to evaluate the rate of silting in the reservoirs. So this is very important aspect, that is silting. Every 5 years once or 10 years once, government undertakes desilting of the rivers reservoirs. You might have heard hoolettadu, that is called as hoolettadu in Kannada. Okay, desilting, which means to say very times the water along with them carries the soil and the other humus particles when the running water, by the running water. Okay, if it is present in the reservoirs, if it is present in the reservoirs on a huge scale, then it causes the storage deficiency in the reservoirs. The storage capacity of the reservoir goes down. So that's why that is the case when you have to do the desilting of the reservoirs also. Okay, and also this is very important. You have to locate the construction materials that is required for the construction of the dam very close to the dam itself, in the vicinity of the dams. That is masonry stones, gravel, sand, and clay for filling. It should be done, or it should be located nearby the construction sites itself. For example, if you are constructing any reservoir or dam near Shumaga, then you cannot bring the materials from Bangalore or Bagalkot or Chikmagalur or any other places. Okay, you cannot bring the materials from Bangalore, Mysore, or even from Ballari or Hospete, anything like that, because the transportation itself is very huge. Okay, that also should have been looked upon. So that's why what they say is you have to locate the required construction materials, that is the masonry stones that is required for the foundations, the gravels, the sand, and also the clay that is required for the filling and cutting should be done near the dam site itself, so that it will reduce the amount of transportation. It will reduce the amount of transportation. So coming to the dams, so these are the aspects which has to be looked upon before you start construction any things, any structures. Okay. Now looking at the dams, so dams are the barriers that are constructed across the river to store the water. Okay, so these are the very important aspects. Why are the dams being constructed? It is constructed as a barrier across the river to store water. First important primary aspect of a dam is to store the water, control the flood for irrigation of plants. Okay, once you start storing the water, you can control the flood. Okay, so thereby the excess water that is being run off as a flood will be controlled, and that water can be used for irrigation of plants, and also for generation of electricity, and also for supplying water to cities and towns. So these are the main aspects why dams are being built. Okay, so dams are built in such a way that they are capable of storing the water, they are controlling the flood which is required, they are controlling the flood, and also they serve for the purpose of irrigation for plants, and also for generation of electricity, and also for supplying drinking water to cities and the towns. For example, BRP, Bhadra Reservoir project, is being built in such a way that it can produce a small amount of electricity, okay, and also from which they leave the water, drinking water, to the parts of the areas adjacent to the Tarikere, Bhadravati. Okay. Irrigation is the main aspect. Bhadra, upper Bhadra and right bank canal and left bank canal, which goes across the Chitradurga and Davangere. Okay, and up to Haryana you can see the left bank and the right bank canals. Up to Rani Benur and other places you can see the left bank and right bank canals, so that the water is being let through the canals, which is utilized for irrigation. Okay, so the flooding is also being controlled. So these are the main purposes for which dams are being built. Okay, so a dam which serves more than one purpose is called as a multi-purpose dam. For example, if it is built for only one purpose like irrigation, then it is a single purpose dam. Now if it supplies both the electricity, irrigation, and also drinking water, then it is serving for multiple purposes. It is used for multiple purposes. It is used called as a multi-purpose dams. There are two important types of dams. One is a concrete or masonry dam, and another one is a earth fill dams. Okay, so concrete or masonry dams are the ones which are built. Concrete or masonry dams are the ones that are built from the rigid concrete using the sand, fill, clay, gravel, cement, boulders, all these things, and they are classified into three types as gravity dam, arch dam, and a buttress dam. So earth fill dams are the ones that are used for small projects with a small maximum height of 100 meters, which are either constructed by soil or earth. So these are usually ones that are being built across the in villages. You can see most of the earth-filled dams in the villages, where then small they use the small gravels and pebbles and small boulders, and they use this soil itself, red soil, for stopping the water. Excessive flow of water is being stopped there. So all these things. But this Tunga Dam, Bhadra Dam are the ones which are being built of the concrete or the masonry dams. Coming to the gravity dam, so gravity dam is a solid masonry or a concrete structure which is generally of a triangular profile, which is designed that it can withhold a pre-calculated volume of water. Okay, so calculation of water that can be held by a dam is already pre-calculated. So this much amount of water is being stored means that much amount of water only can be stored in the reservoir. Okay, excessive water, if it is starting to be stored, then it causes failure for the dams. For example, 186 meters is the highest level of the Bhadra Dam, okay, beyond which you cannot store the water. Okay, once it exceeds 180 meters or 182 meters, they start releasing the gates, because excessive storage of water will cause failure for the dam. Okay, so that is pre-calculated volume of water. So 186 meters is the pre-calculated volume of water, and that is calculated by the virtue of the weight of the dam itself. What amount of weight the dam is being present, then it can be given in such a way. Okay, so all the forces rising in such a dam as due to the thrust of the impounded water and also the massive weight of the dam material. Okay, so those are directly transmitted on the foundation rocks. Hence, the strength of foundation rocks is very important factor here. Okay, so strength of the foundation rocks, that is your rocks, if it is mostly of the igneous or metamorphic origin, then they can withstand very great pressure. If it is of sedimentary origin, then the pressure it cannot withstand very much pressure, because sedimentary rocks are very fragile in nature. They can be broken down by the process of sedimentation. Very easily they can be broken down, whereas igneous or metamorphic rocks cannot be broken down very easily. Coming to the buttress dam, what happens in a buttress dam is that it carries some buttresses within them. It carries some spikes within them at the basement itself. Okay, so it is being provided with some spike-like structure. Now, if you have seen some cricketers or the athletes, they wear the spike shoes, is it not? So that it gives extra grip for them while running or while playing. Okay, athletes and the cricketers, usually even the hockey players also use them. Even the football players also use the spike wears. Okay, spike shoes, so that it gives the extra protection for them towards running, okay, or towards playing. Okay, so even this buttress dam is done in such a way that a small amount of spikes is also being given at the bottom, so that extra grip is being given to the dam safety, so that the dam will not be failure. Dam will not be a failure. Extra concrete or thin concrete slab is supported by downstream side by buttresses. Buttresses means some amount of spike material is being employed into the ground. Okay, so that the spikes will hold the ground very tightly, and most of the dams will not cause any failure, or it will not cause any failure to the dams. Okay, so the upstream face in the gravity dam may be vertical or it may be inclined. The axis of the dam may be straight or a curvature may be induced in the designs also. So the buttresses in such a dams are narrowly heavily loaded structures. Okay, so basement of the buttresses will be very heavily loaded, so that the load is taken into the foundation itself, not on the structure. Maximum amount of load is given to the structure, so that any failure will be directly impulted into the foundation itself, not on the structure. Okay, so the rocks will be exceptionally strong under the buttresses. The rocks that is used as a foundations will be very strong, very strong as a buttresses. Okay, so coming to the arch dam, it is an arch shaped solid structure mostly of concrete. Okay, mostly of concrete. It is being designed. It is designed in such a way that a major part of these thrust forces acting on the dam are transmitted mainly by the arch action. Okay, in Kerala, you might have seen one of the reservoirs, which has filled after 40 years. I think I cannot remember the name very clearly. Okay, that dam is also in the form of a arch structure itself. Okay, Sarovar, Sardar Patel Sarovar in Gujarat, it's also in arc shape itself. Okay, so the abutment rocks, that is rocks forming the left and right sides of the stream valley itself. Dams built even on those sites where foundation rocks may not be sufficiently strong. Even though the foundations rocks may not be sufficiently strong, you can build the dams because it has got the rocks on both the left and right sides of the stream valley. Okay, when stream valley process the rocks on the left and right sides of the abutment, then you can expect some amount of the strength to the dam also. So coming to the earthfield dams are the dams which are non-rigid structures which are built over wide valleys. So usually there are no foundations, and even if foundations are being present, then they are made up of available earth materials and rock fragments. They do not bring the materials from somewhere else, but they build the foundation from the available materials local by itself. Very locally itself, if the materials are being available, then they do such things, foundations. Okay, so then generally they are of trapezoidal shapes. They may be made up of one material or combination of many materials. Okay, usually what happens in earthfield dam is that they make the material from one material, make up the foundation, but also by the combination of many materials. They can be construction even over weak foundations also, even over very weak foundations also they can be constructed, and also they are commonly built with properly compacted core of an impervious materials such as clay material. Okay, even the clay is also used as a filling or a filler. Okay, so coming to the problems that are associated with the dam sites, so these are the problems that are usually associated with the dam sites. Most of the dam failure are not due to the faulty designs or construction, but they are mainly due to the negligence of the geological factors. Okay, by the negligence of the geological factors itself, the dams cause failures. The failures of the dams can be caused. Many a times you can see even the Koina reservoir, which is being built across a faulted structure. Now, if a very small earthquake also occurs, then the entire dam might collapse. It will collapse one day or the other because it is being built on a faulty structure itself. If one dam goes, then there are thousands of crores of rupees that is being gone. Okay, for construction of a dam, it will not take 1 rupee or 2 rupee, or it is not even in a matter of hundreds or thousands or lakhs. It goes into crores level, not only crore but hundreds of crores. Okay, for construction of a dam, it takes hundreds of crores, and if one failure of a dam takes place, then hundreds of crores of rupees is being wasted. So that's why whenever they do such things, that is your either your satellite missions or this dam structures or anything like that, they have to be very careful because hundreds of crores of rupees are being invested into the project. And if it causes failure, then it causes hundreds of crores of rupees to be wasted, and also along with which some of the lives may also be taken down. Okay, so with which I'm going to stop my discussion here. So from next tomorrow, I'm going to discuss on the problems associated with the dam sites. If you have got any questions, you can raise your hands and ask me the questions. All of you drop your attendances now. If you have got any questions, you can ask me. Otherwise, I'm going to stop my discussion here. If you have got any questions, you can raise your hands and ask me questions. Otherwise, I'm going to continue my discussion next class. Thank you.
Hello, sir. Hello.
Yes, Salim, tell me. Danish, tell me.
Sir, I am joined yesterday, sir. I want the
Okay.
notes regarding.
Okay. In Google Classroom, you'll get all the material that is required. Okay.
Sir.
I'll send you the code once. I'll drop in the code once again to the class. If you have joined the class very later, I'll drop in the code that is required for the Google Classroom. You can join the Google Classroom and you can see the notes and the materials.
Yes, sir. Google Classroom, sir.
Yes, I'm going to send the link. Okay.
Yes, sir. Okay, sir.
I'm going to send the code for the Google Classroom. You can join them and then you can have the notes and other things.
Yes, sir.
Okay. Salim, I think you have raised your hand. Okay, left the class. Okay, no issues.